All right, what we're doing here is multiplying radical expressions together and then simplifying them. So like on number 13 here, since they have the same index, and it says this in the, these aren't really directions, but more of just a hint here. Yeah, when you have radicals that are have the same index, you can just multiply the expressions inside together. So what this would first come out to be is negative 4 times the cube root of, well, 16 times 6 is 96. And then x squared times x squared is x to the fourth. Yeah, you're going to want to do that first. I wouldn't suggest simplifying each radical first. I would go ahead and just multiply and then just simplify once at the end. So yeah, now it's possible this simplifies, and I can tell it's going to because we have an x to the fourth and an index of 3, so we can at least take out an x. But so let's do that. So let me break this up just like we did on the front side, and then we can go ahead and keep that negative 4 out front. All right, so the 96, we need to see if we can take out a perfect cube out of it. So 96, 16, I just, for some reason, like breaking down 96 that way. It seems to come up a lot here, doesn't it? 96. All right. Okay, so we need groups of 3. So we have a group of 3 2s, and then we're left over with 3 numbers, actually. So we can take a 2 out, and that's going to get multiplied by the negative 4. And then we're going to have a 2 times 3 times 2 left inside. That's going to be 12. Okay, so that's that part. And then here, I think I'm going to stick with this method. I think this is a little easier to think about. This is x to the fourth. We have one group of 3 x's, 3 because of the 3 here. So you can take out one of those, and then you're left with that inside, like so. And now we just, I'll go ahead and multiply those together too. It's negative 8, and put it together with that x. And then the inside of the radical, we have cube root of 12x. All right, so that's how these work. Let me have you guys do numbers 15 and 17. 17's got a 5th root in there. We haven't seen that before, but just apply the same ideas here. You're going to look for a group of 5 numbers or 5 variables when you break it down. So I'll let you do 15 and 17, and I'll show the answers after you work on them. All right, so what I got for number 15, I got 2x times the cube root of 15. Yeah, so you break down the number, you end up having a group, one group of 3 2s here. All right, so yeah, and then the 3 times 5 is left over, 15. And then the cube root, you end up with an x cubed right after you multiply those. And so the cube root of x cubed is just x, and that ends up there. 17, that was a little trickier. You multiply these, you get negative 4,096. Here's how 4,096, one way to break it down. It basically ends up being 2 to the 12th power, 2 times itself total 12 times. So you have 2 sets, or 2 groups of 5 2s, and so you can take out a 2 for each of those groups, and then you're left over with a 2 times a 2 inside, so that's the 4. Now, I broke down positive 4,096, right? And this was negative, so that's why there's that negative there. This 4 was just the 4 from here, okay? And then you multiply that out, and so you end up with this. And then and I'll get down to what I did here with the negative later. So the variables, you get b to the 10th, right, using the product rule of exponents, add the exponents. And then basically there's 2 groups of 5 b's, or in other words, 10 divided by 5 gives you the 2, right? You can think of that as a rational exponent like that, 10 divided by 5, and so you get b to the second. And so that ends up out front. Yeah, with any odd numbered radical, if there's a negative on the inside, you can actually just move it outside, okay? That's perfectly acceptable to do. If you think about it, the fifth root of -4, that could break down into the fifth root of -1 times the fifth root of 4, right? Breaking that down. And the fifth root of -1 is -1. So you can end up with a -1 on the outside and multiply by whatever's out there. So that's totally okay to do. The shortcut, this is kind of the explanation, but the shortcut, you can just kind of take the negative out there. That works for any odd index root there. If you want some extra practice, go ahead and do 14, 16, and 18, and I'll show the answers afterward. 14 and 16 are here. 16, you had kind of a large number you had to break down, but still the tree isn't that huge. So don't be too intimidated by these bigger numbers. Oh yeah, I just noticed, well, I got the 13,122 by multiplying these two, so that was my first two numbers that I broke it down into. That kind of helped. And then number 18, that one was a little frustrating because you didn't really simplify it much. I went ahead and did the tree, but there's no group of 5 of the same prime factor. And then a to the fourth doesn't have enough a's in it to take out an a, right? You need a number bigger than that.